Okay, I think there is no question since it's so easy for the first week homework. Okay, now we move on into the second homework. This is kind of complicated. Okay, this is kind of complicated. I think it's just, this is also just for substitution, I think. But from what I see for your submissions, uh, you guys, for your submission, you guys don't define the stopping criteria. But I don't know if Mr. Ilham tell you for the stopping criteria. Is Mr. Ilham already tell you about the stopping criteria for this some work? Or just do it for like 20 iterations, or stop it at this? I defined it, the stopping criteria is this: true relative error is less than, just same as for first homework. Like, so I use the criteria stopping point is true relative error less than, like that. I think Mr. Hyun didn't tell you about the stopping criteria, I think. So the question is, you're designing a spherical tank to hold water for a small village. The volume of liquid it can hold can be computed as a meter cubic, and H is the depth of water in tank and in meter, and R is the tank radius M. If R is 3 meter, determine the depth H so that the tank holds 30 meter cubic. Solve the problem using graphical method, dissection method, and regular VLC method. So the true reference value used for error checking is 2.02 meter. And the stopping criteria, this is, I define it by myself, is the true relative error less than 0.010%. By the substituting the R is 3 and the V is 30 into the tank volume formula gives like that. Gives this formula. And for graphical method, okay, for graphical method, we have to, I think you have to use GeoGebra, or if you could use a tool, software tool, you could use GeoGebra. This one, for the graphical, is like that. So from wide view, it seems like the point is between 2 and 2.1 because it's so close to 2, but it's greater than 2. But if I zoom in, we already know that this is not in the exact 2 values, but this is greater, slightly greater than 2. So, okay, so I estimated for 2 until 2.1, and this is the value. The negative, the value change, I mean the plus minus is changed in 2.02 to 2.03. So maybe this is 2.025, like that. And the sign, I mean the sign change between this one and the graphical estimate, I think is the H is 2.03 meter. This is for graphical method. But I know maybe for the first quiz you couldn't use uh, the software or something like that, because I think it's hard for you guys to draw the P uh, formula and there's a P inside. But I think for first quiz, the formula is not as hard as this. Maybe the formula is just like you already know in high school. Maybe just quadratic formula, or you maybe already know in first calculus, I think. Or maybe Mr. Hilham will give you the graphic, already give you the graphic, maybe, if there is a problem with graphical method. So true absolute error is just 0.003 meter, and true relative error is 0.15%, and approximate relative error is not defined for graphical method because we only estimate it's not one iteration, but for a graphical method there is no iteration inside, so there is no approximate relative error. So I estimate the h for the height for the graphical method is 2.03 meter, and we have true relative error is 0.15%. Also, for p-section method, the p-section method starts with the interval a 0 and p is 3. There's in the problem, I think. Yeah, use initial cases of 0 and r, which is the r is 3 meter. Okay, first we check the signs of the functions at the endpoint. So for f0 it's negative 30, and for f3 is 26. Since f0 times f3 is less than 0, which is negative, because this is negative and this is positive, so a root exists in the interval of 0 until 3. You already know this formula from the PowerPoint. So the midpoint formula, because this is p-section method, so we have to compute or calculate the midpoint. XR divided by 2. And this is the formula for approximate relative error and the true relative error you already know. So for the first iterations, A is 0 and P is 3, and for XR is 1.5. So for F1.5 is negative 12. Since F1, wait, no, this is oh, sorry, I mistyped this. Since f0 times f1.5 is greater than 0, because this is negative, and f0 is also negative, is greater than 0. So since f1.5 times f1.875 is greater than 0, so we change the left side interval, which now it's 1.875 until 225. And we could make a table like that. And from my criteria, I assume that the criteria is same as first week homework. So we stop it at 13 iterations. So for my assumptions, this is the h is approximate is 2.0269 meter. And for the last method is regular falsi method. For regular falsi method, also start with the initial interval, which is 0 until 3. And the formula used is like that. So XR, basically, we just change the midpoint formula into new formula. B minus, for the numerator is FB times A minus B. For the denominator is FA minus FB. And the approximate relative error and true relative error you already know. And the first 3 iteration is like that, 0 until 3, and we compute for F0 and F3, and I don't know for the name for this. I just call it like midpoint. So for no, regular falsy point. For regular falsy point, we know X is 1.59, and we just compute the F 1.59, and we get the result is minus 10. And since the F, I don't know, F regular falsy point is greater than, no, less than 0, the new interval is left side. We change the left side from 0 into 1.59. Wait, I have to look at first. Okay, and the PowerPoint is not telling which is okay. It's just like XR is not on the curve, hence the false position translate as regular falsy in Latin. No, I think it's not like that. Okay. So for regular falsy point, I think we use this uh conclusion method, I think, for since the regular falsy point less than 0, we change the left side of the interval, but if the regular falsy point is greater than 0, we change the right side of the interval. Oh no, this is all of the regular falsy point is less than 0. Okay, for second iterations, we just change the regular falsy point this formula, using this formula, and we just only substitute in the formula of spherical tank volume, and we get the result is negative 1.01. And since this one is less than 0, so the left side of interval is changed to this new regular falsy point. For third iteration, same like that. We just substituted. This is for my answer. Uh I don't round it into two number behind the commas, but I think it's fine if you guys round it into two numbers. But I think the error is just bigger. But okay, it's okay. And this is for the third iteration. And this is the table. For this regular falsy method, it's just only 5 iterations, because the truth value is basically 2.02, and this is already closer to the truth value. So for 5 iterations, we already get the minimum error. So the conclusion is, for graphical method, we estimated the age is 2.03 meter, and for bisection method is 2.0269 meter, and for regular velocity method 2.0268 meter, and stop at iteration 5. So for the fastest method for this problem is the regular level C1. Okay, any questions? Okay, it's Humaydi Shafiq, if you have any questions.
I just want to ask Mas, like, how do we, from where do we calculate the true value in the beginning because it was not there in the question?
Oh, yeah. I think for first quiz, the truth value is just given by Mr. Ilham, because we uh, couldn't compute the truth value. This is I using the use the software. Okay, so it answered your question. Because for numerical computation, the uh, goal is not we find the truth value, but we approximate until it reach close to truth value. So the truth value is included in the problem. There is no way you calculate
Okay,
the truth
thank you,
value.
Mas.
Then I don't know why in this question is not given the truth value. But for first quiz, uh, but maybe I have to ask Sultan. For last year, because you in first semester, is the truth value is given in the problem or not?
Given, Mas.
Oh, okay. Because I already forgot. Okay, the truth value is given in the problem.
Okay, thank you,
So
Mas.
okay. From what I see from your submissions, I think most of you guys not define the stopping criteria because this problem that not define the stopping criteria too, but it's fine if you guys like assume by yourself like the stopping criteria. I use stopping criteria same as the first week quiz. It's fine, but it's okay if you just maybe you do it like 40 iterations, but for this dissection method, it's the relative error is still big. Or if you just use maybe 4 iterations or 5 iterations, it's easier if you define it the stopping criteria. Okay, any questions? Any questions again? Okay, I think it's done for second week homework. Move on into third week homework. I will not give you the answer because I think the deadline is still next week, but I will give you the clue. This is basically the same questions, but we just using the another method. So for first method is fixed point, and for two is Newton-Raphson, and for three is second method. Use the initial cases is 0 and same 0 till 3. Compute through a relative error and approximate relative error, which is still the same. The reference root like that. And stopping criteria, I use this one. I think this is difference because I assume by myself. And for fixed point, you guys already know like we have to change the formula, the formula into h equal something, and uh, this is for my formula. I think it could be different from another group, but I use this formula h equal to root of uh 3v per p times 9 minus h. So because wait, I have to open the PowerPoint for week 3. Okay. Like that. For fixed point, like from y equal to something, we change into x equal to something. Because for fixed point iteration, we update the value of x from a formula out of x. So this, now for this one, this is y equal to x plus power of 2 plus 5x plus 6. And we just change the, modify the formula into x equal to another formula. And from this one is, I define it y as, v as y and h as x. So we have to modify the formula until h equal to another formula. And since the goal of the v is 30 meter cubic, so we substitute the 3 into v in is 90 per pi times 9 minus h. Okay, this is for convergence check. Because there's if you maybe it's not wrong, but it's complicated. But you have to check the convergence sample or this is divergent. Because if this is divergent, is bigger the iterations, the error is just bigger. It's linear. But for the convergent, if you bigger iterations, the error become smaller. So we have to know like the formula that we modify have to convergence sample. And how to check it? How to check it is just we differentiate the formula. Maybe you already know in the first calculus. I assume you already know how to d per dx formula something. And how to check it? Like we d per dx the formula of this, and we evaluate at the root true value. And since the absolute value of the d per dx is less than 1, so the iteration is locally convergent. And this is for just check it. And for iterations, wait. The first one is start with 3 for initial cases, and we get the value is approximated 2.18, like that. So we use the previous result into x in the next iterations. So we use the 2.18 into second iterations. This one substituted the h. So we get the approximate value for second iteration is 2.05, and then for the third iterations we use the 2.05 for the third iteration. So this is the formula of h equal to something, but we already know like this number, we use it into fx, which this one. Eh, wait, is it I wrong? No, no, no. Yeah. So this h value, I use it in this volume formula, but I minus 30 since the coal is 30 meter cubic. So if this one value is likely to zero, is then the stopping criteria. And for the table, I'm not showing the table because still the deadline is still on next week, I think. For Newton-Raphson method, this is just the change the how to say the formula. For next iterations, we use previous result of h minus fx per d per dx derivative of fx. So this one is I assume you guys already know in the first calculus how to derivative the formula something. So we get the derivative of fx is this one and start with initial of 3. And for the first iteration, we get x is, or h is 2.06, which is closer to truth value. And for the next iterations and just third iterations, I think for the third iterations is just so close to the truth value, and I won't show the full table because this this is still open submission. For the second method, this formula is just basically we just change the formula for Newton-Raphson. So we use for the next iterations is previous iteration minus fx per times previous iterations minus this one iteration now current iterations per fx for previous iterations minus fx. So we have two initial cases from 0 to 3, and we get the h is for the first iterations is 1.59, and we change the right side, no, left side of the interval is 1.59 until 3, and we just substitute in the formula. And for the third iteration, it's just the same. Okay, this is for third homework. Any questions? Okay, no questions? Okay, I think it's done for discussion about homework. So I will give it to Sultan for discussion about solution of last year quiz. Okay,
Okay, allow me to continue. So let me share screen first. Okay. because I got the information that you guys will have the numerical computation quiz simultaneously with Bu Bilkis's class. So I got the last year's quiz, the problem with the solution. And in my experience, the question is not that different year to year. Like my quiz is not that different from last year's quiz. So I'm going to discuss about the questions. Okay, I'm going to go it quickly because it's pretty much the same with the one Mas Dana has already discussed. He is going to see how you guys will uh, answer the question. Okay, for the first question, it's to find the root of x using the bisection method. Given that the function is this, x cubed plus 6x squared minus 19x minus 84. The lower bound is minus 4. The upper bound is 3, and the true value is minus 3. You guys will get the true value. And to answer this, we're going to use the formula this to find the xr, the middle point between lower bound and upper bound. And then to decide where to go after each iteration, you guys will use this rule. If fxl times fxr is lower than 0, then the root is in the first subinterval or in the left. If it's bigger than 0, then the root is on the second or the right side. And if it's equals to 0, then you may stop because you already get the root. xr equals to root. Okay, so for the first iteration, you guys will search for the XR. This is the lower bound uh, plus the upper bound divided by 2, and then you guys will get minus 0.5. And then if for each iteration, you guys will search for the error true using this formula. And the first iteration's error true is 83.33%. After this, you guys will search for FXL, that is 24, FXR, which is minus 73.13. You guys only need to round it by 2 decimal places for book build case quizzes. After you got two of this, you times it and see whether it's bigger or lower. And because the result of FXL times FXR is less than 0, we may conclude that the root is in the first subinterval or in the left. And because of that, we transfer the value of of xr to xu, the upper bound. After this, we go to the second iteration. We search for the xr like the previous one, and we also search for the error true, and it ends up to be 25. And starting from the second iteration, you guys should also search for the error approximation or EA. And the EA here is 77.78%, rounded to 2 decimal places. We then search for FXL 24, FXR minus 22.27, and we search for FXL times FXR. And because it's less than 0, we may conclude that the root is on the left or the first subinterval. And then we transfer XR to XU. For the third iteration, we do the same exact thing. Search for XR, search for ET, and search for EA. After the third iteration in book build case quizzes, you may stop because I don't think there will be question regarding the fourth iteration. They usually just ask what's the XR for the third iteration, what's the ET for the second iteration, and like that, only like that. Okay, we continue to the second question. The second question, we need to find the root using the false position method or regular fallacy. The function is still the same as the previous one. The lower bound is minus 4, upper bound is 3, and the true value is also minus 3. Nah, For the false position, the formula is like this: xr equals to xu minus fxu times xl minus xu divided by fxl minus fxu. Uh, okay. For the first iteration, we going to search for xr. We just substitute the xu, the xl into this formula, and then we search for the value of f3, f minus 4, and another f3. And then we calculate this, and then we got that the xr equals to minus 2. And then we search for the error true using the same formula as before, and then we got that it's 33.33. Then we search for fxl equals to 24 and fxr we got it to be minus 30. And because fxl times fxr is less than 0, the root lies in the first subinterval or the left side, and we transfer the value of xr into xu for the second iteration. For the second iteration, we use this xu to be the new xu, and then just use the same formula. We substitute this. The xu is minus 2 and the xl is still minus 4. And then we calculate this, and then we got minus 3.11. After this, we calculate the error true, and then we calculate the error approximation too. We got this 3.7, 3.96, 3.67, and the error approximation is 35.69%. We then got the FXL to be 24. It doesn't change because XL is still the same. And then the XR, we got it from using this new XR minus 3.11. And we got that FXR equals to 3.04. Because FXL times FXR is greater than 0 this time, then we can conclude that the root lies in the second subinterval or in the right side. And because of this, we transfer the current XR into the new XL. So this minus 3.11 becomes the new XL. And for the third iteration, it's basically the same. We search for the XR. We got it that it's minus 3.01. We search for the error true. It's 0.33%. And the error approximation is 3.32%. Okay. Now we continue to the third question. We need to find the root of x using the simple fixed point iteration. But we move the variable x. Oh, there's supposed to be x to the left side. So in this question, we move this x, the one with constant 19, to the left side, and the other to the right side. Uh, and in this question, we start the x0 from 3. The function is still the same, okay? So for this function, we're going to seclude this 19x to the left side, while the other, this x cubed uh, positive positive 6x squared and minus 84 to the right side, like this. And then after we seclude 19x, we divide both sides by 19 so that x is alone in the left side. And after this, we can get the iteration formula to be like this. Nah, for the first iteration, we want to search for x1. So we use the x0, that is 3, and substitute it to xi in this formula. We substitute 3 here and here. And after we calculate this, we will get that the x1 is equal to minus 0.16, rounded to two decimal places. And for the second iteration, we do the same. We use the first iteration x1, that is minus 0.16, and substitute it to the formula here, xi here. So we just substitute it here and here. And then after we calculate this, we will get that the x2 is equal to minus 4.41. And for the third iteration, we do the same. We use minus 4.41 and substitute it to x here and here. We calculate this and get that x3 is equal to minus 2.79. And then we will stop at the third iteration. Okay. Nah, for the next question, it's basically the same using fixed point iteration. And the function is also the same, fx point equals to x cubed plus 6x squared minus 19x minus 84. I'm sorry because I disconnected. Wait. Okay, we will continue because the function is still the same. But in this question, we move the x cube to the left side, not the x. Uh, like in this question, we move the x, the one with the constant 19, to the left. But in this question, the fourth question, we will move the x cube, this one, to the left and the other to the right side. So it's going to be like this. And the x cube is alone in the left. And after that, we divide both sides by x squared, so that it can become only x in the left side. After this, we get the iteration formula to be like this. For the first iteration, we will search for x1 using the x0 given by the question. This equals to 3. So we just do the same as the previous one. We just uh, substitute 3 into the equation and get that x1 is equal to 9.67. For the second iteration, we do the same. We substitute 9.67 to the equation. We calculate this. And then we will get that x2 is equals to minus, minus 3.14. Okay, for the third iteration, uh, we will do the same. We just substitute minus 3.14 to the formula, calculate this, and then we will get that minus 3.53 for the x3. Okay, now for the last question, we will need to find the root of x using the Newton-Raphson method. The fx is still the same. The function is still the same. But in this question, we will start x0 from minus 4, not 3. Nah, the formula of Newton-Raphson is this. Xi plus 1 is equal to x, the previous x, minus fxi divided by the derivative of fxi. Nah, for this question, we first need to search for the derivative of fx. So we will get this using the formula you learned at first calculus. So the derivative of fx is equals to 3x squared plus 12x minus 19. And then for the first iteration, we kind of just substitute the x, x0 here, it's minus 4. Minus 4. And then we calculate this. Oh, we also need to search for f minus 4 and the derivative of f minus 4. We got it to be 24 and minus 19. We calculate out this and it equals to minus 2.74 down to two decimal places. And then we will do the same for the second iteration. We use this as the new x minus 2.74. We substitute it here and then we substitute it to the function. So it's f minus 2.74 and the derivative of f minus 2.74. And we calculate this and then we will get this minus 2.99. And for the third iteration, we will do the exact same thing. We calculate this and then we will get that the x3 is equals to minus 3. Okay, do you guys have any question? Do you guys have any question or not? I will wait until 11:07. 11 past 7 minutes. Oh, for this Zoom meeting, there is no attendance because this tutoring session is highly optional and there will be recording after this Zoom. Okay, because this is 11 past 7 minutes and there is no question, I think we can conclude this tutoring session. I'm going to stop share. Okay. Thank you for attending this tutoring session. If you guys have any question, please just use the form or you can just private chat me or Mas Dana. It's okay. Thank you. Uh, Wassalamualaikum warahmatullahi wabarakatuh. You may leave the Zoom. Thank you, thank you.